In both the standard method and the p-value method for hypothesis testing, the first step is to state your hypotheses. So in this video, I want to take a closer look at how to set those up. There are two types of hypotheses: the null hypothesis, denoted by H sub 0, alternative H sub A. So we typically call these just null and alternative. And it's very important to properly designate which one is HO and which one is HA, since the testing procedures do not treat these hypotheses interchangeably. They do have a very distinct role. In particular, they really are designed to favor the null hypothesis. So more often than not, we'll go with the null hypothesis. So the idea that this is not going to be rejected. We're going to assume this is true unless we have data that presents very strong evidence against it. So it's kind of like we're saying this is innocent until proven guilty. We want to assume it's true unless we have very strong evidence that it is not. But this does have implications of the fact that if we don't reject this, that doesn't mean it's true. It's only that we don't have enough evidence in the data to reject it. We don't have enough evidence to say it's false. Doesn't necessarily mean it's true. Going back to the innocent until proven guilty analogy, just because we do not have enough evidence to say someone is guilty does not mean they are not guilty. We're just assuming innocence unless we have really strong evidence. So that doesn't necessarily mean H0 is always going to be true if we do not reject it. It just kind of gives us a basic idea saying that there's not enough current evidence to say that it is false. As a result, whenever we set these up, this is the one that we want evidence for, or we're trying to prove. So we want to try to prove the alternative hypothesis and assume the null hypothesis. So we will assume this one's true, and we want evidence for this one. Another value that's going to be very important is the level of significance, which is denoted by alpha. This kind of gives us a quantity on the reasonable doubt we are willing to accept when we reject our null hypothesis. It tells us how much evidence we need before we can go with the alternative hypothesis. So this level of significance tells us exactly how much evidence we need to support this claim here. And then one other thing to note, the equal sign is always part of the null hypothesis. So it'll always be neither an equal, a less than or equal, or greater than or equal to. Equality is always part of our null hypothesis. A trucking firm suspects that a tire's manufacturer's claim that a certain tire lasts at least 28,000 miles on average is faulty. So they want to initiate a study involving data collection and hypothesis testing to provide evidence supporting this position. So let's set up this hypothesis. We need our null and our alternative. We are looking at a mean. We are looking at an average, so we're going to be using mu. Alternatively, we could be looking at a proportion, in which case we would use p. This firm is looking to build a hypothesis to provide evidence supporting the position that this is wrong. So they want to find evidence that it is not at least 28,000. The original claim was that it was 28,000 or more, so greater than or equal to 28,000, and they want to provide evidence supporting that this is false. So mu is less than 28,000 would be our alternative hypothesis, because this is what we are looking for proof for. We now have that a tire manufacturing firm wants to claim that certain tires last on average more than 28,000 miles. And the firm intends to initiate a study involving data collection and hypothesis testing to support the validity of this claim. So they do want to provide evidence for the claim, for the fact that it is more. So we want evidence on the fact that it is greater than 28,000. So in this case, my null hypothesis would be less than or equal to 28,000, the opposite of the alternative hypothesis.